Hey, so this video is made to help with the undetermined coefficients homework. And so I'm just going to do an example that's based on this problem on My Open Math, where we're given a system of this form here, which is our second order system. So if this was set equal to 0, then if this right-hand side over here was 0, then we could solve that using the characteristic polynomial and generate that solution fairly easily. The method of undetermined coefficients, of course, is to allow us to solve for inhomogeneous problems. So that's where we do have something on this right-hand side here. And it's particularly effective for problems that have exponentials or trig functions on the right-hand side. Because for those, you'll see that there's kind of a pattern the way that we can generate a good guess. And so undetermined coefficients is basically a educated guess technique for solving these differential equations. So it takes a bit of practice to get good at making good guesses for these. But the idea here is that, so for a function that's of this form, I want to guess something that looks like this. And so the A and B here, we're going to end up solving for those to find that one particular solution. And the reason that I would pick something that takes that form is that if I pass that, so we're thinking of plugging this function in with the A's and B's as unknown constants. When I plug that into my left-hand side here, it's going to poop out something that looks like a squiggle plus b squiggle x times e to the x. So it'll give me something back of the same form out on that side. And of course, it'll scramble up these constants a bit. The a squiggle and b squiggle are going to be jumbled up a bit, right? They won't just be the a's and b's. But we can then choose those to match, right? So we're going to choose the a squiggle to be minus 24, and we're going to choose the b squiggle to be 16. And if we can do that, then we've found a solution that satisfies the differential equation. So really, we're going to plug in this form, and we're going to group the terms so that we can try to match these up here. And that's the entire idea. All right, so I'm going to take this form, and I'm going to start plugging it in to my equation, right? Or my left-hand side up here. So you can see I've got second derivative of it minus 7 times y prime. So let me just write what we're plugging into, plus 10, and then this is y there. All right, and then you just have to do some calculus, right? So this is second derivative of this. Every one of these terms is going to have an e to the x in it because that persists through derivatives. And so I'll get x plus 2 here minus, here's these terms expanded, and then these terms expanded. And what I've added here is that I went ahead and wrote in my right-hand side. So that's this term up here, e to the x minus 24 equals 16x, right? And the idea is we're going to try to choose these a's and b's so that we can solve this. Oh, and then you can see I've already canceled the e to the x's. Those are going to appear in every single term over here. And of course, we put them in there because we need it to cancel the e to the x that's on the right-hand side. So this leaves us with a polynomial. So this is just recopying without the e to the x's. So here's my jumbled up term that's passed through the equation equals this right-hand side term without the exponential. And then what we're going to do, just to bring it back here, we're going to figure out what the a squiggle and b squiggles are. So those are going to be the coefficient of x and the x to the 0th power terms. So group all these terms together over here in blue that don't have an x involved in them. So the a gets here plus 2b, etc., minus 7a, minus 7b, plus 10a. So that gives me all those terms. And then the terms that involve x's, I get bx and minus 7b. and plus 10b, so net 4b x. And then I'm going to set those equal, right? So I'm going to take blue equals blue, and this purple equals purple, right? And so that gives me the purple equals purple one is pretty easy to solve. 4b is 16. That tells me b is 4. And then I took that right up here and plugged into my other equation, simplifying this a little bit. And I'm going to get 4a, blah, blah, blah. So I can solve that, and I get a equals -1. So the proof that this is a solution is all in the pudding here, because we were able to solve it, therefore such a solution exists, right? And the whole idea here is that we just need to find one solution. So my y particular was e to the x a plus bx. I just found what a and b need to be to satisfy my right-hand side, so therefore the particular solution is e to the x -1 plus 4x. So for many, this is just one example of this, but they're all going to have the same sort of flavor here. And I'll just point out that let's say that I had a right-hand side that looked like e to the -2x, 1 plus 6x. So, can't get that to go away. Then instead of guessing e to the x, of course, I'm going to guess e to the -2x now, because we need that term to appear on both sides to be able to solve, right? And my derivatives will now, instead of just being e to the x back, I'll get -2 e to the -2x whenever I take that derivative. But the procedure remains the same. It's the bookkeeping that becomes slightly more difficult. As you work through this homework, you'll see that there's different guesses for different types of problems, right? So this kind of, any time you now see something with an exponential here, then you know that you're going to guess some guess of this form, depending on what this function is here, to be able to solve. Okay.